Good evening all. Am I audible? Dr. Bharatraj Singh, good evening. Ananta Shrikar, good evening. Shubhangi, good evening. Venkata Raghavendra, good evening. Srinivasulu, good evening. Ranjana, good evening. Am I audible, guys? Are you able to hear me properly? Yeah, thank you for your response. Okay. Akanksha, good evening. Yeah, thank you all for your valuable response. Shubhangi, good evening. Satyapriya, good evening. Tejas, good evening. Kami Reddy, good evening. Balamurugan, good evening. Ratnesh Kumar, good evening. Okay. Manisha, good evening. So, this is Indra from Pantech Learning. Today is our third day of this 21 days masterclass on STM32 Nucleo, right? So, for the first 2 days, we have talked about what is ARM, what is STM32, how to download and install that particular STM32 Cube IDE software. Have you given it a try? Do you? Yeah, Abhishek, good evening. Bharatraj Singh, good evening. Barsha Reddy, good evening. Preksha, good evening. Madhuri, good evening. Have you tried? Have you downloaded and installed STM32 Cube IDE in your laptop or PC? Do you face any difficulties while downloading and installing process? Yeah, good evening, Saira. So please give it a try and do it by yourself. Then only you can able to understand how we do what we are going to do. That's why I'm repeatedly saying this. Give it a try by yourself. Then only you can able to know that, right? Okay. So if you face any doubts or if you face any difficulties while downloading and installing that software, in the sense, you can come to me and I will clear it out, right? Yeah, Tejas, very good. Okay. So for the first 2 days, we have just talked about the theory part. I'm sorry for that. Today also we are going to talk about the theory part only. Today is the last day. From tomorrow itself, we can go for the remaining stuff, which is programming part, component interfacing part, everything. Because today what we are going to talk about that, what board we are using and what are the pinouts, what are the features, what are the application that particular board have. For that we need to know, right? So what are those pins, why we are using all those pins, everything. For that today we are just going to talk about the particular board which I am going to use in this entire masterclass. Okay. We good to go? Let me start. Okay. I am using STM32 Nucleo F446RE board. Okay. So this is actually low cost and quick to use a development board. Okay, this comes around like 1700 something rupees. So it has an ARM Cortex 32-bit microcontroller. Okay, that comes only in a single package, LQFP. So in STM32, okay, so one is used for STM, which are male pins, and the second are female pins, which is actually used for Arduino. Okay. So tomorrow I will show you the board. Actually today I am not taking the board with me. So in the tomorrow session I will show you how to use that board, how the board will actually look like. Today I just have some screenshot and I have some pictures of that particular board only, right? Okay. So see, all types of Arduino headers can be attached to this board. Okay. So STM32 boards give all kind of modern communication and debug system for industrial and home based with like 84 megahertz processing speed. So at the commercial level, the board builds an excellent reputation within a few decades and increases daily. Okay, so now let's start. Okay. So now, are you able to hear me properly now? Is it clear? Okay. So now let's talk about pin configuration of STM32 Nucleo. Okay. So see this, here I provided the picture of the board which I am going to use in this session. This is the board, it will look like. This is what the pins which are all present in the board. Okay. So these comes under Arduino board. These two comes under Arduino board. If you see or if you have Arduino board with your hand in the sense, you already know that how Arduino board will look like. So these pins are for STM32 and these are for Arduino pins. You can connect Arduino board in the STM32 board itself. Okay. Okay. Yeah. See the pin configuration of STM32 Nucleo. It is a little different from other boards. Note this. This is actually little different from the other boards. It actually supports the multiple IDE. Okay. I didn't tell that you should only go for STM32 Cube IDE. There is so many IDs over there. But I recommend STM32 Cube IDE because it's official for, this is only for STM32. That's why I go for it. You can use any other software like HAL or something like that. Okay. You can choose anything. That's not audible. Are you able to hear me now? Is my voice is clear? Am I audible now? Okay, fine, thank you. Okay, see, here the male pin, these are the male pins and these are the female pins. So the male ones are the STM32 pin and the female pins are for Arduino. So the female pins can be attached to any Arduino supported shield or module without using any third device. You can directly attach any type of Arduino board into this STM32 board. Okay. So the header is nothing but these are the headers CN5, CN6, CN9, CN8. These are the header or for Arduino. Okay. And CN7 and CN10 represent STM32 Nucleo board. This is how you can call your pin name. So these are corresponding to the Arduinos and CN7 and CN10 only correspond to STM32. Okay. So now I am here with the valuable information. So you can convert this masterclass into 1 month internship. So the registration fees is for 1,999, but that is a discount amount which is available for you, which is only for 799. So this is the registration link. If you want, grab this 1 month internship on STM32 Nucleo 64 in the sense, you can go for this link and make your registration. So the last date to register is 14/9/2024. Okay. So what you will get in this 1 month internship? You will get 30 days of live session, 30 days of recorded session, 30 days of presentations for download, 5 project source code for download, 1 month internship certificate, participation certificate, 90 days of access to the courses, 4 hackathon live session, and you can join to the community group. Are you able to hear me properly? Am I audible? Are you able to hear me properly now? Now? Is this clear, guys? Are you able to hear me? Okay. So these are the things you will get in this 1 month internship. Okay. And also there is a 3-in-1 bundle course is available for you. So you can choose any 2 courses from these 4 courses. So STM32 is the default one, you can't change that. From among these 4 courses you can choose any 2. Raspberry Pi, Arduino, Internet of Things or ARM Cortex, you can choose any 2 by your own. So the registration fees is actually 3,000, but there is a discount amount which is available for you, which is only for 1199. So this is the registration link for 3-in-1 bundle course. So the last date to register is 14/9/2024. Use this chance wisely. So what you will get in this 3-in-1 bundle course? So 90 days of live session, 90 days of recorded session, 90 days of presentations for download, 10 project source code for download, 3 internship certificate, 1 year validity to all the courses which you have applied for, hackathon live session, and you can join to the community group, and you will have your assignment and mock test. So while making your payment, don't forget to add the courses that you want. I already told you that STM32 is a default one, you can't change that, and you can add any 2 more courses from those 4 courses, right? That's completely depend on your choice. So while making your payment, don't forget to add the name. Okay, now coming back to the topic, now let's talk about STM32 Nucleo digital input and output pin. Okay, so see, input output pins, so these are from the right side pin, this is the left side pin. I have totally shown, see here you can see this, right? So this is the total pin. Here I have put the screenshot of the picture, like this is from the right side and this is the left side. Okay, so see, the input output pins are the basic requirement for every circuit. In STM32 Nucleo there are a bunch of them. Some came from Arduino pin and some came from STM32 pin. It is a combination thing, right? So the input output pins are lower in number as compared to STM32. Okay, so here all the input output pins of STM32 Nucleo are, see this, here you can see, like they have mentioned the pin number over here from 1 to 38, and this is the CN10 category, and this is for CN5 and CN9. This is totally for Arduino, and CN10 is totally for what? STM32. So see, here you are having like 38 pins, but each pin consists of so many functions. So if you want to use it as a GPIO pin, in the sense you can use it as a GPIO pin. If you want to assign that particular pin in a pulse width modulation or like ADC, which means analog to digital converter, you can. Here you can see that over here, right? So these 3 pins, you can use it as a GPIO pin, you can use it as a ADC pin, you can use it as a pulse width modulation pin, and also you can use it as a communication protocol, which is nothing but SPI, serial peripheral interface, clock pin, meso pin, MOSI pin, like that. So each pin consists of so many functions. For that you have to select what function you are going to play, and you have to mention that particular pin as this pin. Then only the board and program get to know that okay, this pin is corresponding to this function only. If you are performing SPI, in the sense you have to mention that particular pin. This pin I am going to play a SPI role. If you want to play ADC, in the sense you have to mention that particular pin as ADC, pulse width modulation, accordingly. Okay, so these are the left side pin. So same like that, you can see here, right? So CN6 and CN8 is for Arduino, this pins, and these are CN7 is totally for STM32 pin. NC is nothing but not in use, no connection, something like that. You can't use that particular pin, which is what called NC. Okay. Now see, so here I provided all the pin number and all the function name over here in CN7, in CN10, in CN5, in CN8. You can use accordingly. So here you can able to see the pin number here, like PA13. There is 3 parts: PA, PB and PC. Part A, port B, port C, something like that. You have to mention the pin number correctly. So pin number is different, GPIO number is different. Okay, I don't know what problem you are having. Am I clear? Are you able to hear me properly? Is my voice slow or okay? Are you able to hear me, guys? Is this clear? Okay. See, if you are saying GPIO 1 means that pin is not corresponding to pin number 1. GPIO 1 is different. The GPIO 1 pin is corresponding to the pin number PC10. While you are programming, you can't mention it like 1. I mean the first pin. Okay, GPIO number is different and the pin number is different. So GPIO 1 corresponds to PC10. While you are programming, you have to mention the pin number properly. PC10. If you are taking this PC10 as LED pin, in the sense you have to mention that I am taking that particular pin as LCD. I am going to set the mode to output. So PC10, you have to mention it like that. You can't give like GPIO 1 or something like that. If you give GPIO 1 in the sense, it will take some other pin like that. Okay, so you have to mention it properly. So GPIO 3 is correspond to what? PC12. That's why I mentioned all those pin number here. So PC10 is corresponding to GPIO 1. If you want to take GPIO 5 in that sense, you have to mention it accordingly. So PB9 corresponding to GPIO 5. So I have provided in CN7, CN10, in CN5 and CN6 over here. So this is for CN7, CN10, CN5 and 9, like right side and left side separately, right? Okay. Okay. So this is for pulse width modulation pins. These are all pins are corresponding to only pulse width modulation pin. See, the Nucleo F446 RE has multiple pulse width modulation pin. Okay. So pulse width modulation pins are available in both STM32 and Arduino. So all pulse width modulation pin can generate the desired output signal to control the external peripherals. Okay, so these pulse width modulation pins use a pre-scaler to break the single cycle of the clock pulse to generate the output signal. So the pulse width modulation pins are in C7. You will have like 5 pins like GPIO 17, GPIO 9, GPIO 28, GPIO 30, GPIO 34, something like that. So in CN10 you will have pin like almost these all of the pins comes under pulse width modulation. So in CN5 and CN9, these are all the pins which are for D3 is nothing but PD3, PD5, not PD3, sorry. These are for, these pins comes under Arduino pins, okay? Okay. So in Arduino pins, we just call the particular pin like D. D is nothing but digital input output pin. So D3, D5, D6, D9, D10, D11s are for Arduino pin. In STM32, we call pin like PA series, PB series, P3 series. There is only 3 series: PA, PB, PC. Okay. So now serial communications in STM32 Nucleo UART communication pin. So UART is nothing but this comes under communication protocol. UART is nothing but universal asynchronous receiver and transmitter. While we go for the particular communication protocol topic, UART topic, you will get to know what is UART and why we are using all those steps. Here I am just coming with the pin we are going to use. Okay, so don't confuse yourself. I will explain everything in the later session. Okay, so there are multiple UART communication pin in this particular Nucleo F446 RE board. All these pins allow multiple UART module to communicate with the board at a time. Okay, so the UART on Arduino only allows communicating a single UART device. I am repeating this: the UART on Arduino only allows communicating a single UART device. Okay, so in CN7, in CN10, in CN9, these are the pins that we can use for UART communication. Okay, and coming to the next communication, which is SPI communication pin, serial peripheral interface communication pin. So SPI protocol are also a kind of serial communication that actually uses 4 wires for communication. If you are taking UART and I2C, that only takes 2 wire for communication, but in SPI you have to connect 4 wire for communication. So 2 for clock and device selection and 2 for data. Okay, so multiple devices of the same kind can be controlled by a single SPI module. So in Nucleo F446RE has multiple SPI pins, which are I have mentioned over here. In CN7, in CN10, in CN5, you can take any of these pins for SPI communication. So I have already told you that SPI have 4 pins. So clock, meso, MOSI, chip select pins is a one set, and another set is different pins. So you have to take 4 wire for SPI communication. And then let's move for the next communication protocol, which is I2C, integrated chip. That's what we call I2C, IIC. Okay, so there are multiple pins for I2C protocol also. It is based on 2 pin only. One is for clock and another one is for data. So these pins can communicate with external I2C modules. Okay, so in STM32 Nucleo F446RE, both type of header support I2C communication. So here I mentioned all those pins which we use for I2C communication. In CN7 there is I2C one, SDA is nothing but data pin, SCL is nothing but clock pin. Okay, now here comes ADC channel, which is analog to digital converter channel. So there is total of 16 channels of AD on the board. Okay, so all these channels are 12 bits and they exist in both type of header. So the ADC allows the external voltage to convert the analog signal to digital. So here I provide all the ADC pins which we can use in the board. In CN7, in CN10, in CN8, you can choose any pin from these thing. Okay, so now here comes analog reference. See, STM32 Nucleo allows the developer to add the analog voltage reference by which ADC will be able to measure the input value. So the analog reference voltage pins are available for STM32 and Arduino 2. So these are the pins we can use for analog reference. In CN10, AVDD pin, which is correspond to GPIO 7. VDD is nothing but positive, the power pin. A, G and D means analog ground pin. And here voltage reference pin. Okay. So now power pin of STM32 Nucleo power input. So see this. There are multiple power pins and methods to power up the board, and all of them are, the first thing is power input. There are multiple power input pins for both board. Okay, I am talking about Arduino and STM32. So the STM32 board can be turned on by using the 3.3 volt and 5 volt, but the whole board can only power up through 5 volt. Okay, the power pins on Nucleo 446RE and Arduino are I provided here in CN10. In CN6 there are so many pins to power up your board. You can choose any one of this, or you can just directly give the USB cable to power up your board from your laptop or PC, something like that. Okay, now coming to the power out. So the boards given the power output of 5 volt and 3.3 volt. All the 5 volt outputs are connected directly except VBAT and E5V. So VBAT and E5V have protections and only for input. The other 5 volt, E5 means nothing but external 5 volt. Okay, so VBAT means battery pin, like that. So V in pins or all headers can be used for 5 volt. So the 3.3 volt pins are connected through regulators. So all the output pins are here, you can see in CN7 3.3 volt, in CN10 U5V, in CN6 3.35 volt, 5 volt, V in pin, something like that. So you have so many pins in your board, and input output reference. So in case of using the 3.3 volt for power up the device, in the sense the IO ref, input output reference pin, should be active. It will allow the board to operating according to 3 volt. So this particular pin is only in the whole board and it common with Arduino pin also. The pins are GPIO 12 and GPIO 2, and then oscillator pin. So the board has internal oscillator of 16 MHz and 32 kHz. So for Arduino IDE, the oscillator should be 16 MHz, but for other IDE, the crystal can be varied to choose from internal or external, something like that. Okay. So the board also offer the external crystal pin, which are in C10. There is two things. One is GPIO 29 and GPIO 31. And coming to the reset pin, here see, board also support multiple reset. It has a pre-installed reset button in the to the board manually, but it also offers an external pin for the reset the board. So the reset pin in common between Arduino and STM32. In CN7 you will have like GPIO 14 pin, and in CN6 there is GPIO 3. So these are comes under the pin description. Don't get confused by all of these pins number. When we are going to the programming part, when we are going to the connecting part, I will explain everything clearly, then you will understand it easily. I'm just explaining all those steps what are present inside the board and everything, so don't get confused about this, right? So if you just connect the USB cable to your board and PC, in the sense, that is much enough to power up your board. But I have to explain all those stuff, why we are having this pin, what are the function of this pin. That's why I'm explaining everything like that. Okay, so don't get confused and don't go for the pin, which pin I have to connect for which this voltage, that no, nothing. You just need a USB cable. Okay, that's it. Okay, so again I'm coming with this. You can convert this masterclass into 1 month internship. So the actual amount of this internship is for 1,999, but there is a discount amount which is available for you, which is only for 799. So use this registration link to make your registration. So the last day to register is 14/9/2024. So in this 1 month internship, you will get 30 days of live session, 30 days of recorded session, 30 days of presentation for download, 5 project source code for download, 1 month internship certificate, participation certificate, 90 days of access to the courses, 4 hackathon live session, and you can join to the community group. And also there is a 3-in-1 bundle courses available for you. You can choose any 2 courses from these 4 courses, and STM32 is a default one, you can't change that. So the actual amount of this bundle course is for 3,000, but there is a discount amount which is available for you, which is only for 1199. So this is the registration link, and make your registration. The last day to register is 14/9/2024. So what you will get in this 3-in-1 bundle course? $90 days of live session, 90 days of recorded session, 90 days of presentations for download, 10 project source code for download, 3 internship certificate, 1 year validity to the courses, hackathon live session, and you can join to the community group, and you will get assignments and mock test. So while making your payment, don't forget to add the courses that you want. That is the mandatory thing. So don't forget to add the courses name, right? Okay. So here I provide the Nucleo block diagram. This is how our microcontroller will look like. This is the STM32 microcontroller part, and this is the embedded ST link. I have already told you that STM32 Blue Pill board is a beginner board. For that, while if you want to upload your program to that particular board, in the sense, you need to externally connect this the ST link connector. But in Nucleo board and Discovery board, you don't have to go for the external one, because it is already present, embedded inside that board itself. So this is how your board will look like. This is the ST link part, and this is the microcontroller part. And here I provide all those features, STM32 Nucleo board features, microcontroller which is 32-bit, and this is not the actual board that I have used in this session, which is 446 RE. Here I provide 401. Okay, so CPU frequency is 84 megahertz, and the power supply for the microcontroller is 1.7 volt to 3.6 volt, and we in the board 7 volt to 15 volt. ADC is 12-bit 16 channel. There are totally 8 timers. Watchdog timer, yes, it is available, and all those communication protocols are available. UART is available, 3 I2C communication protocol is available, 3 SPI is available, USB 2.0 is available, internal clock oscillator 16 MHz, external oscillator 4 MHz to 26 MHz, onboard debugger is available, flash memory 512 KB, static RAM 96 KB. And coming to this STM32 Nucleo F446RE peripherals. Coming to these peripherals, first one is debug. So the board supports multiple debug method, which allows the user to test and program the controller in multiple ways. Sometimes method developers can find it difficult due to their limited data on the internet. And coming to the USB can be attached to the board through pins and its USB port. So it supports the PC to install the drivers automatically and link the board to it without relying on any third interface. So this is not only limited to the STM pin, but it also has an internal burner for both Arduino and STM pins, which can be used directly from computer. And coming to the board cut, I have already told you that in the single board itself you can have two parts. One is microcontroller part, other one is ST-Link part. So the board can be cut into two pieces to minimize the size. Okay, so the board has two parts. One is ST-Link and another one is microcontroller. It could cut down to two pieces, and the remaining controller part can be used. After cut it down, some power input will be specific to some pins, and the remaining GPIO will be the same. And coming to the last thing, which is indicator. LEDs are used for the indication of the multiple values and data for powering up LED, uploading LED, something like that. While we are going to the programming part, you will get to know all those stuff. So some LEDs are directly attached to the GPIO pin to test the simple function to avoid extra wire, like that, right? So this is all about today's session. This is all about the board part, everything. From tomorrow itself, there is no more theory part. We just directly go for the programming part. We are just going to play with the microcontroller, get the output, get the result, and we are going to learn about that, right? I hope you understood all those topics which we have learned for these past 3 days. So this is all about today's session. If you have any queries or doubt in the sense, you can ask me. Anything else, guys? Is it clear or not? Do you have any doubts? You got the attendance link. That's why you didn't even respond to me, right? Okay, fine. So this is all about today's session. Let's catch up at tomorrow's session with another topic. Thank you all. Have a very great day.